Alright, so here we have another circuit and just some more information of things we're supposed to find. So we're supposed to find the current I. Now notice that this circuit just is one big series circuit, so everything should have the same current. So if we find one current, we've found them all. And we're supposed to find V1, which is the voltage across the 2 kilo ohm resistor, so that'd be V1, and V2, which is the difference in voltages from the upper terminal to the lower terminal. So like for instance, if I called this VA and this VB, then V2 would equal VA minus VB, because it's the voltage at the positive terminal minus the voltage at the negative terminal. Alright, so let's see. If I look at, okay, so this is how I would do this one. There's lots of ways to do it, but I would start off, I would make this bottom node ground, and then that tells me with this 10 volt voltage source relative to ground, above that has to be 10 volts relative to ground, and above this 4 volt voltage source has to be 4 volts relative to ground. So if I'm just labeling everything relative to ground, then it would be 10 volts here and 4 volts here. So now if I want to find the current I will equal VA minus VB over the resistance between those two voltages. So if I'm starting at 10 volts and going to 4 volts, I would equal 10 minus 4 over the resistance between them. Well, those are two resistors in series. So two resistors in series, I can just add those together. That'd be 3 kilo ohms. So I equals 6 over 3 kilo ohms, or I equals 2 milliamps. Okay, so now the next thing it says is to find the voltage V1. So when it's asking for the voltage V1, that means the change in voltage from the plus side to the minus side. So that's just Ohm's law. So that would be V equals I, 2 milliamps, times 2 kilo ohms, or V equals 4 volts. So V1 equals 4 volts. So this is 2 milliamps, and this is 4 volts. Now we're supposed to find V2, and there are, again, lots of ways to do this, but I think, I mean, I'll do it a couple ways. So V2 is the voltage, it's a VA between VB. So that would be equivalent to, since VB is at ground, it's at my reference node, so if I call VB 0, then VA would be the voltage relative to ground. So I already have marked that this is 10 volts relative to ground and this is 4 volts relative to ground. So if I could find out how much voltage, how much of a voltage drop there was across the 2 kilo ohm resistor, then I could find out what the voltage is right here relative to ground. Well, that's easy enough to do because actually I think I already did it. Did I? Yeah, because I found V1. So V1 was 4 volts. And so going across V1, you're going to lose 4 volts. So it's going to go from 10 volts to 6 volts. And so you lose 4 volts going across. And so at this point right here, you're at 6 volts. And relative to ground, that is 6 volts. So V2 is 6 volts. Another way to do it is, let's say I did not have as much information as I had, and all I had was that I had this set up. So I have my two resistors, and I knew it was at 10 volts here and at 4 volts here, and I wanted to find what the voltage was there, and this is 2 kilo ohms, and this is 1 kilo ohm. Well, I can do voltage division, which tells me what the voltage change is over one of these resistors. And so if I wanted to find the voltage drop across the 2 kilo ohm resistor, that would equal the entire voltage drop, which is 6 volts, because going from 10 to 4 is 6 volts, times the 2 kilo ohm resistor over the sum of both resistances, so 2 kilo ohms plus 1 kilo ohm. So that's 6 volts times 2 over 3, which is 4 volts, which tells me there's a 4 volt drop across this. So that's another way to find V1. And once you found V1, if there's a 4 volt drop across it, then we're at 6 volts there, which gets us the same answer. Okay, any questions on that one? All right then. I'm going to save this one.